Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to add support for wheeled vehicles into our physics movement component. So this has been a rather lengthy series, and doing a quick little recap. First off, I started the series with mass override, so that we can set the mass of the vehicle as well as move the center of mass into a more ideal position for our vehicle. Then we did engine simulation that allows us to take the controller input for the accelerator and turn that into engine torque. We then created a transmission which would allow us to create both automatic and manual transmissions to take that engine torque and turn it into angular velocity and angular position for our wheels. We also created a steering system so that we could turn these wheels that we want to steer on the vehicle, as seen here. And then finally, we went in a slightly different direction and looked at animation support. So I kind of did that because we're now kind of building up to the real things that I think people really want to know, which is suspension and wheel friction. And in order to kind of do that justice, I really wanted to get the animation out the way first, so that when we get to suspension and wheel support, we can actually start seeing the fruits of those labors that we'll be endeavoring to work on. So this video is probably going to be a little bit of a short video in which we're going to go ahead and finish setting up the asset and tying it into our custom blueprint for our animation. As well as setting up other things on the asset, so we're all ready to go. That way, when we in the following video, we can then move straight into suspension, and then work to get the vehicle standing on its own shock absorbers. And from there, we should be able to see both steering and suspension in play. And then finally, I'm looking. The final video should then be just wheel friction, where we can then turn all of that angular positioning and velocity into thrust on the wheels, so kind of move us across the desert as seen here. So as always, we have a lot of ground to cover, so let's get started. Okay, so I'm going to be using this asset right here, which is the M1126 Striker by Vigilante. I got my asset off the Fab store. If you're having trouble trying to find this on Fab, I'm also going to leave a link to the marketplace that the vendor uses to sell the assets, so you can then pick it up through there directly from the vendor as well. So this is the asset we're going to be using. It's a multi-axial vehicle, which is actually pretty useful when building a wheel system, because if you can build it for multi-axles, then you can build it for two axles, right? But if you know, as I found out, if you build it for two axles, it might not support multiple axles. So start big and then work your way down. That's kind of what I say. So this is the asset we'll be using. I'll leave links in the description below to both places. So this is what we're going to be working with. All right, so after that, I'm just going to go ahead and pull this down. So once you've downloaded it and brought it into your project, you should have a folder called Vigilante Content, and here and under there, depending on how many vehicles you brought down, you should see your APC Striker content folder. So within here, I'm just going to go ahead and I'm going to duplicate two assets. The first asset I'm going to duplicate and change is going to be the physics asset on this skeletal mesh. So I always like to just duplicate it versus actually changing the asset. That way, if there's an issue, I can always go back to the original. So we're just going to do that, update it, and we will just pop this open. And the only thing that I'm actually going to take out is the gun joint for this demo. So I'm just going to go ahead and delete this for now. If you want to, you can always go back to the asset, pick it up again, and then everything else, we're actually going to switch this over, and I'm just going to highlight everything for all of the wheels and the center of gravity joint. And on the physics type here, we're going to switch from default to simulated. So what that's going to do is it's going to tell it to let gravity take control of the vehicle. Now, if you are moving into change it to simulated, and then you want to make the wheels stop acting like wet spaghetti, you can go into each of the constraints and start setting up your constraints. So if you're going to be using, so here, as you can see, everything's set to limited. Just set it to lock, and everything will lock down on the swing. For swing motion 1, 2, and twist. If you're going to be using the constraints, so when I get to suspension and steering, I'm actually going to be using a custom constraint that's actually in the engine to manage it. The Unreal Engine actually does have a suspension constraint system for skeletals, which is hidden away. So I'm going to be using that. But if you're not going to use that, and you want to just and you want something which you could use on both statics as well as skeletals, then you'll need to kind of play with this a little bit. So you'd create a limited, actually you'd probably create a limited Z motion on each of the wheels, and your limit would be your up and down motion for the suspension. And then for twisting motion, I think twisting is limited to steering, where I think swing motion 2 is going to be your pitch over. So you'd probably want to set that to free. And then that would kind of get you set up. So then the simulation would then take over and then decide where to move it. And that's how we're going to be moving all of these things. But I'm planning on doing things a little differently. Unreal Engine actually does have a great suspension system hidden, buried within its code. And so I'm going to kind of show you guys where it is if you're into the C++ world, so that you can kind of leverage that yourself. So we're just going to leave all these constraints the way they are for now. Actually, I'm probably just going to lock everything up for now. If you just want to kind of let this thing be a static object, you can just lock it all down, and the vehicle just look like it is right now. I'm just going to lock it. What's going to happen is that when I do get to suspension, Unreal Engine suspension system will actually remove the wheel constraints completely and replace it with its own suspension constraint system, which is not accessible here. So it's only accessible from C++. All right, so that's all we need to do there to prep the vehicle. And so this is our sim. So let's go over to our striker vehicle, and we're going to go into the assets. And here I'm just going to move this over to use our new asset. And this is just keeping the original asset intact. Then I'm going to do the same thing for the striker showcase. I'm just going to duplicate this asset, and I'm just going to put like sim just like that. And the reason why I want to duplicate this asset is because this is where we're going to go ahead and make our changes. So we don't need anything in this event graph. We're not going to be using these wheel rotations because we went ahead and built our custom animation blueprints, and we'll go ahead and use that. So this is the sim. I am just going to go ahead and close the event graph, and all I care about is the animation graph. We don't need this. So right now this is pretty much this is actually well set up for what I need. The only difference is that I just need to update the wheels, right? And those wheels are going to use we're actually producing that wheel data. So to do that, and so we already have this information here. Our animators created this stuff. We just need to take this animation and format it to our system. And in Unreal Engine, that's actually pretty easy to do since we have our custom animation blueprint. We don't need to create a new animation blueprint. We can actually take this animation instance here and just re-blueprint it. And to do that, we can go to File, say Reparent Blueprints, and then we can come down here, and here's our physics vehicle animation instance. We're just going to click on that, and now we have re-blueprinted our physics blueprint. And as you can see, if you come up to the parent class up here in the corner, you should see that it has now been reparented. So because this is a derivative, we can do that. And so, and this is a derivative of the animation blueprint. So all that work we did in the last video is now here. And so all we need to do is now just go find it. So I'm just going to go right click and let's see if we can remember what that was. Get. There it is. Get bone transform data. So this is the function that we created. I'm just going to go ahead and pull up C++ and kind of show you how this is going to then map into what we're going to do. All right, so if we come into the C++, so what we did was we have this physics animation proxy, which is doing all of the work for us in being able to process the data coming off the simulation as the simulation is in real time and this is being done as the animation is ticking. So the animation ticks, it's going to go over to our vehicle simulation component and ask for the latest version or the latest position information for the rotation and the vector, right, for each one of these bones that we're tracking and managing. And so that's what's going to happen here. And then this is the actual animation instance that we've converted over to. And here is our function here. And remember, in order for this to work within the actual animation blueprint, we also have to make this a blueprint thread safe. So it is. So we just need to pass the name in and we'll get a transform back. And that transform data will then use to update the update the bone information in the animation blueprint. So I'm just going to go ahead and move this off screen. So that function translates to this function, and so what we're going to do is we're going to put a bone name in, and we'll get its corresponding transform out. So I'm just going to go ahead and split this structure. So here we've got a bone name. I'm just going to say copy that, and I'm just going to put that into there. And it looks like I'm just going to have to do a little bit of extra work. So this is the name of the joint that we're going to be mapping. So what we're going to be doing when we actually get to start building out the wheel structures on the other side in the blueprint, we're going to say these are the joints, these are the rotation joints that we care about, and this is the resting position of that joint, and this is how we're going to then map that information to this information so that all of that information kind of links up. And so then from here we have the front wheel. So all I'm going to do is I'm just going to drag that into there, and I'm going to drag the rotation into there, and we don't care about the scale. It can stay where it is, and that's all we really need to do. Now when working with the bone transform, we just need to make sure that we update the translation mode. So right now it's set to ignore. So if it's set to ignore, we can put this information in and it will ignore it. It won't do anything with it. So in order for it to move it the way we want to say add to existing. And that's the same for rotation, but we don't need scale. Right, so just make sure that when working with this guy, translation is set to add to existing, and that the rotation is add to existing. We can still keep it in the component space. We don't need to worry about changing that. And that's all we're doing there. So now we've got this, we can go ahead and create this same function for all 4 of the front wheels, and then we're going to do it for all 4 of the back wheels. So let's just go ahead and do that real quick. Okay, so I just went ahead and skipped ahead a little bit just to set this up for the interest of time. So again, all I did was I just took this function, copied it, and then just made sure that we set the bones up. And so then all we have to do is just make sure that we finish off with the transform. So there's the bone modifier here. I'm just going to come over here, set this from ignore to add existing. Ignore add existing, again making sure that these bones map to these bones. Because what we're doing is in the simulation, we are actually simulating each wheel to determine what we need to do on each wheel. So the more wheels you have, the more data we're going to have. So I'm going to say add to existing. Yeah, so as you can see here, these are additive processes. So we want to use the additive. That way we just update and we're not going to be replacing wholesale. All right, so let's just double check. Add to existing, 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 add, 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 and add. If we didn't do add to existing, then what would happen is that the bone wheel wouldn't move up and down on the translation. So, and if we didn't do that, and this is already set to add to existing, so that by doing so, it's going to allow us to pitch over, and it's also going to allow us to turn it as well. So that's what we're going to do there. All right, so that's all we should need to do on the blueprint. So let's go ahead and create our, and let's create our striker blueprint now. All right, so to do that, I'm just going to come up to the content drawer. Let's go to content. What do we got? Where are we putting all our vehicles? Here we are. So I'm going to put it under movement blueprints. So let's go ahead and create a new blueprint. I'm going to use a pawn class. And let's just call this BP striker. All right, so that's our BP striker. I'm just going to open this up. First thing I'm going to do is add the skeletal. So there's our skeletal mesh. If you're using a static mesh, it would just be a static, and then we just want to make sure we move this into the default scene component slot. So now this is now considered the root component. All right, next, let's go ahead and set up we need to set up the spring arm and the camera. Actually, let's set up the skeletal first. So to do that, I'm just going to go find our new skeletal asset. There's our striker vehicle, and we also have an animation blueprint. So we want to use the showcase sim because that's where our data is. So I'm going to link that up. This is under physics. This is let's use the simulated physics state. And then under collision, we want to set this to, I'm going to set this to vehicle. And that should be good for everything. All right, hit compile. All right, so there is our vehicle. And we're going to need a camera. So I'm going to come back to add and find a spring arm. And on the spring arm, let's add a camera. Alrighty. So as far as the spring arm, I am going to use, let's do a socket, and I'm going to use the center of gravity joint. So that kind of ties us straight into the middle of the vehicle right here. And then off here, let's go ahead and let's see, let's do a offset of 200. So that's going to bring us up a bit. And I'm going to say, let's use a target length of about 900. So we're about 300 here. 900. So that kind of gives us enough distance between the vehicles. And it's a rather large vehicle. So we need to kind of move back to kind of get it into the picture. All right. once we have all of this in place, I don't think I need to add any additional effects on the mesh and the camera. I think we're good there. I think the only other thing I'm going to do is I'm just going to go ahead and bring in the vehicle simulation component, even though it's not finished yet, so that we can just start setting that up. So there's our vehicle simulation, and I'm going to hit compile save. And then under core vehicle, we've got some setup that we can be doing, and as you can see here, we've got all of our original elements, and we're starting to now get our engine simulation stuff here, as well as our transmission and our differential. And as you can see here, we've just got the start of our steering. Do we have the wheels in yet? Yep, wheels are right here. Wheel configuration. So here, as you can see, we could technically start adding our wheels and our wheel class if we created a wheel class. Well, I'm going to hold off on this piece. Again, we don't, we're still working that out, but we can technically start configuring a lot of this other stuff in, so we can start to use it. So I just went and checked the mechanical sim enabled for now. Alright, so let's go ahead and start to set this up. I think the first thing I'm going to do is let's go ahead and create a new input setup for our vehicle so that we can drive it. So I'm going to come into blueprints, come under inputs. So we've got boat, drone, flying cube, heli, jet, and thruster. So let's go ahead and create a new input. Blueprint, input. I'm going to create a new context. Just going to call it IMC wheels. All right, let's see what we've got to work with. We've got a lot of inputs already defined, so we might be able to reuse some of those. So as far as the accelerator, let's just go ahead and reuse the throttle input X. And I'm going to just fire up my controller again so that we can map this. So to map it, I'm just going to hit the keyboard and I'm just going to hit the analog trigger on my controller. So that's going to act as our accelerator, and because I am using an analog, we're going to give it we need to give it a little bit of a dead zone. Alright, so that should do it for that. Brakes, we are going to eventually need brakes. I don't think I have anything here for brakes. So let's go ahead and create a new asset or a new input asset for brakes real quick. So I'm going to come to actions. I'm just going to duplicate the yaw input. Actually, no, I'm going to just create a new one since we haven't done this in a while. So I'm just going to call it IA wheel brakes. I'm going to come in. So since this is going to be an analog, I'm going to need an axis. I'm just going to do that. Save it. Now we're going to come in here and I'm going to go to wheel brakes. There it is. And again, I'm just going to do the same thing. I'm going to hit the keyboard and I'm going to click on the left analog trigger. And because, again, it's an analog, we'll want to give it a bit of a dead zone so that it's not going to take, that way it doesn't, feed input that we don't intend to put in there. So that's what the dead zone is going to do. Let's see, what else do we need? we're going to need, well, if we're going to do manual transmission and automatic, then we're going to need some shifters for the manual transmission. So let's go ahead and do that as well. So I'm just going to go ahead and create a, I think we'll just create an upshift and a downshift. So, and those ones are going to be Boolean. So again, I'm going to hit input and I'm just going to call it upshift, and I'm going to duplicate this. Actually, first off, let's make sure it's set up. Yep, so we just need to keep this as a digital bool since it's going to be used as a digital bool. So keep that. So now I'm just going to come down and I'm just going to say duplicate. And I'm just going to put downshift for now. And let's see if we can save everything real quick, just in case Unreal Engine decides to crash. Everything's saved. All right, so then I'm just going to go ahead and add, this is going to be upshift. And I'm just going to go ahead and just do a quick little add for downshift before I map them. Where is it? There it is. All right, so for upshift, I'm going to go ahead and put that on the shoulder button on the right, and downshift is going to be on the shoulder button left. They're booleans, so we don't need to worry about this. And we don't really need to worry about any modifiers on this, but because I want this to act as a button press, I'm going to go ahead and go into the trigger, and I'm going to tell the trigger to act like a button. So I'm going to use the press here, and I'm going to do the same thing here. So what's going to happen is it's going to, when we press it, it's going to act like it's being pressed. So that's what that's going to do there. So done and done. Okay, so we have we've got our upshift, downshift if we're going to use manual transmission. If we're going to use automatic, we don't really need to worry about this too much, unless we need to pop it into drive or pop it into reverse. And then we've got our accelerator and our brake. So I think that's all we need there. So let's go back to the striker, and I'm now going to go into the event graph and let's start setting up the input stuff. So to do this, what I'm going to do is I'm going to go into another blueprint. Let's go into the jet real quick. So this is our jet, and I'm actually going to take this input mapping struct and that we've done in the jet and all the others, and I'm going to bring this over to the striker. It's the same kind of setup, so we might as well just reuse it. And so what's happening here is that pretty much on the received controller change, it's going to go in, it's going to take a look to see if this is a player controller. If this is a player controller, if this is a valid player controller, then we can then use the enhanced input player subsystem tied to that controller. And then I'm going to make sure that this thing is valid before we try and use it. Otherwise, if it's not valid, we've got a problem. So if it's valid, we'll come up here and we will set this to our IMC wheels package here. All right, I think I could take that out and that out, and I could probably take that out. All right, so that should set up our input mapping. So let's go ahead and take a look at setting up the component to receive our inputs. All right, so let's go ahead and start setting this up. So let's start with the accelerator and the brakes. So on the accelerator, I'm using the throttle X. And while I'm here, let's go ahead and get the brakes. And I'm also going to get the upshift and downshift. And it looks like I'm missing steering. So let's go ahead and fix that real quick. So I'm going to come back to wheels. I'm just going to go ahead and repurpose your input, since it's since we already have it defined and steering is an analog. So I'm just going to go ahead and add that. I'm just going to find our AI. Where is that? There it is. Your input. And I'm just going to put this on our steering. So I'm just going to be using the gamepad right thumbstick for steering. If you want to, some people might use left, some people might use right. It's up to you. And again, this is, we're going to need a modifier because this is an analog. So let's add the dead zone modifier in there. All right, so now we come back to, we probably close the jet now and come back to the striker. Let's go ahead and add the steering back in. And there it is, your inputs. All right, so if I come to vehicle simulation, we can pull off, and we should have those functions there that we created earlier on. So let's find the set throttle. So there's our set throttle input. We're just going to hook this up real quick. Put that in, and I'm going to set this to engine simulation only for this setup. And then for brakes, I think we should have a function which is set wheel brake input. So I'm just going to go grab that. There, that's wheel steering. We can put this for your. Let's find my wheel brake inputs. Do I have? Oh, don't have brakes yet. So we haven't got the brakes yet. So we'll hold off on that and we'll just set up what we have. So we have steering, we have upshift, downshift. We are missing the brakes because the brakes are part of the wheel, are tightly coupled to the wheel simulation. So we'll come back and fill this in when we're doing the wheel system. But it's there ready to be used. And then what we have here is our shift up, shift down. So let's go ahead and do that. All right, so here's our set gear shift. So our set gear shift is one function, right? And so if is upshift, we're just going to put a boolean in, and I'm just going to copy this for downshift, and remember to take the check mark off. So again, if we're shifting up, we're going to be passing in a true. If we're shifting down, we'll pass in a false if we're manually shifting gears. All right, so with the exception of our wheel brakes, and we'll get to that when we get to wheel brakes, we've got everything else here set up. And we've also got the steering set up, so that's all good to go for when we're ready to implement or start seeing that in the animation. Let's see if there's anything else. What I'm going to do is I'm going to do a quick little button here to allow us to see the side of the vehicle versus the back of the vehicle. So right now what we've done is we've set it up so the camera sees is in the back of the vehicle. And this is great if you, for driving, and this is probably where you're going to need the camera. But for debugging purposes, let's just go ahead and put a little debug camera change. so that we can kind of see the camera in 2 angles and just move the camera. So to do that, I'm just going to put a debug key. So I'm going to set this to debug key 5. And I'm just going to put it in a flip-flop. So there's our flip-flop, and off here I'm just going to go grab the spring arm, and I'm just going to do a set relative rotation. There it is, set relative rotation. So if I hit the key, I'm going to set the set relative rotation to 0, which puts it back behind the vehicle again. But if I click it here, I'm just going to move it 90 degrees. There we go, move it 90 degrees. And that should do it there. So that'll help to turn us a little bit. See what else can we do here. I'm going to hold off on the UI a little bit. We can come back to that. Just checking my other example real quick. All right, so yeah, I think I'm going to hold off on adding some of this right now, and let's just go jumping into configuring let's just start configuring the pieces of the vehicle that we can configure, so we're ready to go when we come back to suspension and wheel friction. So let's go ahead and do that. So let me bring up the wheel vehicle. So coming into simulation component, let's go ahead and just start with the engine simulation. So let's get this data looking good, and then from engine we'll go to the transmission, set that up with the gears, and then the differential as well as the steering. So we'll just go finish off this so that we can kind of emulate the other my other project. All right, so let's get started with the engine. So for the engine, I'm probably these numbers are probably going to be a little low for something like the kind of vehicle that we're working with, but they work. So I'm just going to use these for now. So for max torque, so this is the maximum torque that is coming off the engine. I think I'm actually using values for a BMW M5. So yeah, just throwing that in a striker. Why not? So I'm using 650 torque, so that's the maximum torque value, but that's not necessarily evenly being distributed across the entire, RPM threshold, right? So you have these revolutions per minute, and as the engine gets faster, it's going to it's putting out torque, right? But there is a threshold in which the torque we go up to max torque, and then we start to see a torque drop off in the engine. So, and that's what the torque curve is going to be doing. So here, as far as the max RPM, I'm going to keep that at 4,500, and as far as the engine idle, I'm going to bring this one down to 250. Brake efficiency 0.5, that can stay there. That's the engine brake. So again, this is kind of like friction in the engine. Once you take your foot off the accelerator, this is how the engine's going to start slowing the vehicle back down again. RPM up is going to be 600 there. Engine condition, we'll keep that the same. So the only thing we need to do now is go ahead and define our torque, and this takes this is done through a float curve. So let's go ahead and create that. So to create our float curve, just like we did with the drone and the helicopter thruster, I'm just going to go to right, go under miscellaneous, and here's our curve. we've got some options here. So let's pick the curve, and I'm going to pick the curve float. SC. Torque. Okay, so let's open this up. Actually, I'm just going to save this real quick. All right, so what we're going to do here is we're not actually going to plot the I'm not going to plot the efficiency to the curve. So in the code, and I can bring this up real quick. Okay, so in the engine simulation, we have this function called get torque from RPM, right? So we're going to be taking the revolutions per minute that is coming, from the system, from the simulation, right? And from there, if we have a curve, which is what we're going to be implementing, what we're going to do is we're going to take the engine RPM, divide it by 1,000, and that's going to give us a scale value. And actually, whoops, we have a little bit of a bug. We should be using the scale value in there instead. So there's our bug. But what we want to use is the scale value. So what we're going to do is we're actually going to step the engine RPM down from the thousands into a single, into something a little bit more manageable within the curve. So again, a little bit of a bug. We just changed it from engine RPM to scale, since that's what we're doing, and then recompile. And so that's going to allow us to make a more manageable curve that we can use. Otherwise, we would have to plot this instead of plotting this as a percentage to a single integer, we'd be plotting it to an integer in the thousands, which kind of makes this curve like really big. So we're just going to scale it. All right, so let's go ahead and do that. Make the change and then go ahead and recompile, and then that should take the change. So I'll go ahead and do that a little bit later. But for now, let's go ahead and create this curve. So to do this, if you're new to curves, all we need to do is we just need to add a key. And this key is going to represent a position on a two-dimensional grid. And in order to set it, we can come up to the values up here at the top, next to the little eye icon here, and we can go ahead and set this. So what I'm going to do is I'm going to say, so our engine idle is at 250. 250, so but I'm going to go ahead and start, so pretty much I'm going to start it at engine idle, or a little bit below engine idle, but at 0.5 I'm going to set this to 0.75. So what we're going to be doing is at 500 RPM, this would be 500 RPMs, right? We're going to have the engine idle speed be set to the amount of torque coming off the engine is going to be 75% of what we would envision, 75% of the maximum torque. And that's how we're going to manage this torque curve here. Then the next point is going to be at 1, so this is going to be 1000 RPMs. So I'm just going to go ahead and say add key. And at 1 and at 1000 RPMs, we're going to be 0.8. So now we're at 80% at 1. So, and then at 1.5, I'm going to add a key again. And this is going to be 85%. So as you can see, our torque is we're getting closer and closer and closer to max torque, and so we can use this torque curve to control, and the combination of this curve and max torque to be able to determine how much torque based on the revolutions our engine is doing. So that's how we're going to calculate our torque value. Then we're going to add another key at 2. And at 2000 RPMs, we'll be getting 90% of the max torque. at 2,500. And again, you can make this as, you can, make this as intricate as you want. If you want to make it more curvy versus linear, you can go ahead and do that as well. It's up to you on how you want to set this up. But each curve kind of represents how the engine's going to perform. So this is going to be along the lines of more of a naturally aspirated engine. So it's going to build up and up and up and up and up till we get to the maximum number of RPM or max torque, or maximum, the most efficient point where we're going to get max torque for the RPMs, and then it'll start to drop off as we go beyond the maximum RPMs again. So there's this curve. A turbocharger would go up quicker, and then it would be flat, more like a tabletop before it drops off. Versus a supercharger would probably go up a bit, and then it will tabletop at the end, because superchargers give you more power at the higher RPMs versus turbochargers give you power at lower RPMs. So you can use these curves to determine what your characteristics of your engine are based on the max torque. And so that's kind of how you can kind of set this up. If I can find the reference material, I'll try and put a link to that below on what I was using to kind of figure out how to best set up your curves. But again, that's kind of just a general knowledge. You can kind of research this, go onto Google and find out what, and each engine, based on its configuration, will tell you how you want to set up your curves based on the max torque. All right, so let's see. We've got 3. This is actually going to be our max torque for this vehicle. This is kind of what I'm kind of setting up. So at 3,000 RPMs, this is where this is our peak efficiency of our engine. So at 3,000 RPMs, we get 100% of the torque. Then as we get beyond 3,000 RPMs, so 3.5, we're going to start to see a power drop off a little bit. So here, 3.5, I'm going to go back to 9.8. And at 4, get out of the key, we're going to see 9.6. So that this drop off isn't awful, but it's slowly dropping off as we go past max torque. And then when we start getting into we're getting to the point where we're over revving the engine, we're now going to be getting into, we're going to start seeing and this will be at 4.5. So this is the maximum safe RPMs of the engine before we start blowing the engine up. And then if we were to get to a 5, well, we've probably blown the engine up at that point. Or maybe 5.5. So I'm going to put it at 0.72. So that's kind of our curve that we're going to be using. So I can save it. I can close this, and if I reopen it, it should actually scale it a bit better. So there it is. Again, this is just scaling it a bit better. So that's the curve that we're going to be going up to peak efficiency, and then after we get to peak efficiency, we should then start to see a power drop off on the engine. All right, so let's go back to our striker and go ahead and put that curve in. All right, so there it is. So again, that curve is going to match us to the maximum torque. All right, so now that we've got the torque in there, let's take a look at the gear sets and set up the transmission. All right, so to set up the transmission, we'll keep it in automatic. So the final drive ratio, this is technically kind of like the gear size for your vehicle. So I'm using a 9.25. I could either make this better by either upping the amount of torque off the engine, which is probably more accurate. You think a tank is producing a lot more torque off the engine, but you could also balance that between your final gear ratio. And So this is the final ratio. So when we get to, and then what we're going to be using, well, this is the final gear size. And then what we're going to do is we're going to create ratios off that final gear size. And that's kind of how the gear system is going to work. So I'm going to put in 6 gears for Ford. So 0 to 5, that gives me 6. And again, so again, this is like a BMW M3 gear ratio set. Circa late 90s, early 2000s. So I'm just going to go and put these ratios in. This one, as you can see, the final ratio is actually here, and then this is actually, the last gear is actually an overdrive. In which it starts to get, take a little bit off the final drive ratio. And again, all of this is data, right? So it's just a matter of just figuring out what your data is to kind of get to feed the simulation. And so different data sets, different weights, different number of axles, different amount, change the torque, change the RPMs, change the data, and you'll get a different outcome for your vehicle. So again, this is all data-driven simulation. And then we're just going to have one reverse gear, and that reverse gear is just going to be here. If you want to have multiples, you can add multiples. Works the same way. All right, so as far as the upshifting, since we are a lower shift, I'm going to say 3,500 is going to be our upshift, and I'm going to use 2,000 for downshift. So this is used for automatics. So if you set your automatic transmission, your automatic will upshift if our RPMs get over 3,500. So at that point, and if we go back to our torque curve, right, 3,000 is our optimal peak, right? So as we start to go beyond our optimal, right, we probably want to shift up, which is going to then drop the RPMs a little bit so that we can continue to climb back up to optimal. But if we downshift, if we start to drop off from our optimal, we probably want to then downshift. So to get us back into our optimal, get us back to our optimal amount of torque. So again, you can play with this, set it up the way you want it. So if you want more of a sports car shift, you'll probably be dancing around your peak here, versus if you want it to be a little bit more, utilitarian, more like a tank, you'll probably want to bring it maybe a little bit further down, maybe a little bit further down here, because you're not worrying about trying to keep it around that optimal peak here with your gear shifter. All right, shifting time. We'll just keep it at 0.2. And transmission efficiency. So again, this is the amount of this is the efficiency of the transmission. So as like anything else, there's friction. There's always friction loss in a system. So this is going to be the friction loss in the there. All right. As far as differential, this is going to be an all-wheel drive vehicle. So I'm going to set this to all-wheel drive. So in the code, what's going to happen in the wheel setup when we get to wheels, we don't have this piece of code written yet, but what it's going to do is it's going to take a look as it's setting up the wheels, and it's going to take a look at the differential, and based on whether we define the wheel as being a front wheel or a rear wheel, it'll determine whether it's going to say power is going to be set to that wheel or not. And then we have this is our differential split, which we did work on. So this will determine how much power goes to the front axis versus the back axis if we are an all-wheel drive vehicle. All right, so that's set there. As far as steering is concerned, all I'm going to do is I'm just going to keep it as the angle ratio, and we'll just keep the same ratio. And then as far as max steering, I'm just going to go from 30 to 40. And we'll just leave it like that. If you want to play with the speed versus steering angle curve, you can. Pretty much, it's just a curve just like this is, and all you're going to do is you're just going to plot the amount of angle that a vehicle can turn based on the speed. So If you're going at 0 speed, then you'll have the full range of motion. If you're at top speed, right, then maybe this steering angle would be 5% instead of 40. It would be maybe a 5-degree angle. Again, this is kind of creating that, if you're driving a car and the faster you go, the harder it is to steer. Sometimes you'll feel like a vehicle's kind of, it's stiff or it's fighting you to be able to turn. That's, you can kind of bake that into the simulation using this. I'm not going to do this here. But if you want to go and play with that, you can. It's just, again, speed versus the angle. So the idea is we put the speed going in, and then we'll output the actual angle ratio to feed the simulation for steering. All right, let's see. Is there anything else that we can do right now? As far as inputs are concerned, engine and steering, we can keep those the same. We don't need to do anything there. All right, so I think we've set everything up that we can set up right now. There's a couple of, we'll come back to this blueprint as we kind of start building out the systems. We'll come in and build out the simulation stuff for the suspension next, and then after suspension, and we'll then start looking at the wheel brake, and then we'll probably build a quick HUD to kind of so we can see the speed of the vehicle and the braking and the gear shifting. But for now, I think this should do it. We've made some setups. We've started setting up what we can as far as the vehicle. So that should do it for this video. And so in the next video, we'll come back and we'll start going back into the C++ and start building out suspension and applying it to this vehicle here. All right. So as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. If you have any comments, feel free to leave them in the comments below. And I'll see you again in the next video. Cheers and have a good day.